More than 70 million people in the United States go to the movies each week to get away from their cares and to find entertainment, romance, and thrills on the magic screen. But only a few understand how the lights and shadows on the screen are controlled to make us see a motion picture. Motion pictures are based on an optical illusion, just another case where seeing is believing. To understand how we see, let's turn the tables on the human eye and look at it instead of through it. The light, reflected by any object we look at, passes through the lens of the eye and is focused upside down on the sensitive surface called the retina. This retina passes the impression on to the optic nerve, which sends it to the brain, and we see it right side up. The reflection will stay on the retina as long as the object is in view. When we look away or take the object away, the images disappear. But notice that the image in the brain does not disappear immediately. It fades a fraction of a second after the object is removed. This slow fading is called persistence of vision. When we look at a moving object, we really see it in two places at once, where it is and where it was a fraction of a second before. Let's get out into a rainstorm for a good example. The water you seem to see falling in streams is really a lot of separate drops. Persistence of vision makes you see each raindrop in several places over a distance of several inches. Let's look at a picture of a car and a picture of a moving landscape to show how the eye can make them seem to overlap. Let's run them on the screen, one after the other. We look at them for 2 seconds each, then for 1 second each. Now, faster and faster until we see the two pictures as if they were both one picture, another optical illusion. If your eyes didn't trick you into seeing the moving particles of fireworks as continuous streaks, you would see only sparks instead of streams of light. Persistence of vision is the principle which makes movies possible. A motion picture is really only a fast series of still photographs that overlap in your mind. Tracings of two of these still photographs, placed one on top of the other, show that each of the two photographs has caught the press in a slightly different position. Here is the way the first photograph looks. This is the way the second photograph looks. Now let's take the complete series in rapid succession. Faster. Persistence of vision makes us see two pictures at once. As a result, there is an appearance of motion. So motion pictures are just still pictures joined together on a long strip of film. The more still pictures we get while the action is going on, the smoother it looks. If we want to slow down the motion of something that goes fast, we speed up our camera and make, say, 5 times as many pictures per second. We have slow motion when they are shown on the screen at normal camera speed. Now, here is a motion picture film, 1,000 feet, 16,000 separate photographs. Let's tidy up this tangle of film by putting it on a reel. Now we'll build a projection machine to show the pictures on a screen. The film unwinds from the reel and rewinds onto another reel after it runs through the projector. To throw the picture on the screen, there is a bright light with a reflector behind it to send the light rays in the right direction and a lens to concentrate the light. The film passes a hole or aperture which lets the light go through only one picture at a time. There is another lens to focus the pictures on the screen. By adjusting the lenses, the picture can be made sharp and clear. Let's start the machine moving. The still pictures blur because they're moving all the time. And this won't do at all. We need something to hold each picture still long enough for us to look at it in between the changes. When the film is started and stopped in rapid succession, the eye sees the changes being made and the result is streaks instead of movies. So we need a shutter to cut off the light while every change of picture is being made, and let light through only while the film is standing still. Surprising as it seems, you never see a motion picture while it is actually moving. The only time a movie moves is when the shutter keeps you from seeing the change of picture. Then we see it just the way it looks in real life. Now we have the important parts of a projector for showing motion pictures on the screen. But let's change that drawing to an actual machine at work. This reel holds the supply of motion picture film, which passes through the projector at a speed of 90 feet each minute. Slots on this aperture plate guide the film past the narrow beam of light so that only one picture can be seen at a time. The adjustable lens, which gives us a clear, sharp picture on the screen, is placed in the path of the light rays after they pass through the film. Sprockets, which guide the film as well as start it and stop it, are placed in position to hold the film in proper position at all times. The shutter is placed behind the film to cut off the light at intervals while the pictures change. And now, when you see motion pictures, you get a true picture of what really happens. A picture that you could never see in any other way.